When subjected to external forces, if an object is about to move or slide on a floor, then the state of motion of that object is known to be impending motion. Okay, let us discuss a problem related to impending motion in this video. Block 2 rests on block 1 and is attached by a horizontal rope AB to the wall as shown in the figure. How much amount of force P is necessary to cause of motion of block 1 to impend? The coefficient of friction between the blocks is 1 by 4 and between the floor and block 1 is 1 by 3. Mass of the blocks 1 and 2 are given as 14 kg and 9 kg respectively. Data given in the problem. Here block 2 is placed on block 1. Okay, and block 2 is connected by a string AB with the wall. In the problem, it is asked to calculate the required amount of force P to cause impending motion to block 1. Okay. To solve this problem, we can draw free body diagrams for both the blocks 1 and 2 by considering all the forces acting on the blocks. Considering all the forces acting on block 2, this is block 2. It is connected with a string AB, so there will be a tension force along this direction. We can name it as tension in AB, TAB. When the block 1 experiences impending motion by this load P, then the block 1 will try to move along this direction. Okay, along the direction of the applied force P. When block 1 impends in this direction, then the block 2 getting placed on this block 1 will be experiencing a little bit move in the opposite direction. Okay, blocks 1 and 2 are in direct contact, so there will be some friction in between the contact surfaces. So frictional force should be considered in the analysis. The direction of frictional force is always in the opposite direction to the motion of blocks or objects. Okay. Here, for the impending motion of block 1, the possible direction of motion of block 2 is in this direction. So for this direction of motion for block 2, the direction of the frictional force is in the opposite direction. We can name it as frictional force 2, F2 for block 2. Okay. The weight of the block 2 will be acting in the negative y-axis direction. This is W2. Wherever an object is in contact, at the contact point, according to Newton's third law, there will be a normal reaction force. Here blocks 2 and 1 are in contact. So at the contact point, in the opposite direction of the force due to the weight of the object, there will be a normal reaction force. We can name it as NR2. Okay. Now we can apply the equilibrium conditions to solve this problem, because this problem is solved for the impending motion of block 1. Impending motion is nothing but it is the state at which a block is about to move or slide. Okay, so up to that extent the object will be in equilibrium position. So we can apply equilibrium conditions for solving these force components. Okay, first condition, summation of all the horizontal forces acting on block 2 is equal to 0. Okay, we can consider the forces acting along the positive x-axis direction with the positive sign and along the negative x-axis direction with the negative sign. Okay, TAB is acting along the positive x-axis. So TAB, F2 is acting along the negative x-axis. So F2 is equal to 0. Okay, this is TAB. The formula for the frictional force is the coefficient of friction and the normal reaction force. Okay, this is frictional force formula is equal to 0. Here the mu is the coefficient of friction. We are considering the friction between blocks 1 and 2. So in between blocks 1 and 2, the coefficient of friction value mu is given in the problem as 1 by 4. So TAB minus 1 by 4 into NR2 is equal to 0. So TAB is equal to 1 by 4 into nr2. We can keep this as equation 1. Okay. Next, we can apply the second equilibrium condition, that is summation of all the vertical forces acting on block 2 is equal to 0. Okay. We can consider the forces acting along the positive y-axis with the positive sign and the forces acting along the negative y-axis with the negative sign. Okay. Here nr2 force component is acting along the positive y-axis, so plus nr2, and the weight of the second block W2 is acting along the negative y-axis direction, so we can consider that force component with a negative sign is equal to 0. Okay. nr2 minus W2, that is weight of the block. Here mass of the block 2 is given as 9 kg, so this is 9 into 9.81 Newton. Okay. We can get the value of nr2 as plus 9 into 9.81, that is 88.29 Newton. Okay. Now we can consider the force components acting on block 1. This is block 1. It is placed on a floor. During the impending motion, due to this applied load P, block 1 will be at the point of sliding in this direction. So the frictional force will be in the opposite direction to the motion of block 1. So the direction of frictional force F1 will be along this direction. Okay. Here the force component P is in this direction with a horizontal inclination of 45 degree. So we can split this force into two force components, one along the horizontal direction P cos 45 degree and one along the positive y-axis direction P sin 45 degree. Okay. Weight of block 1 will be acting in the direction of gravity. So W1 weight will be acting on block 1 in the negative y-axis direction. Here block 2 is placed on block 1. Okay. So the weight of block 2 will also be acting on block 1. So weight of block 2 should also be considered. Block 1 is in contact with the floor in the bottom and block 2 in the upper side. Okay. So when block 1 is at the point of sliding in the direction of force P, it will be experiencing frictional forces in both the upper and bottom side. Okay. So in the upper side also, block 1 experiences the frictional force in the opposite direction of the impending motion. Okay. According to Newton's third law, here at the point of contact there will be a normal reaction force nr1 in the opposite direction of the weights of block 1 and block 2. Okay. So these are all the force components acting on block 1 during the impending motion. Okay. Now we can apply the equilibrium conditions. The first condition is summation of all the horizontal forces acting on block 1 is 0. Considering the horizontal forces, F2 and F1 are acting along the positive x-axis direction. So F1 plus F2. The horizontal force component of the subjected force P is acting along the negative x-axis direction. So minus P cos 45 is equal to 0. Okay. The formula for frictional force component is known to be mu into normal reaction. So this F1 is the frictional force acting between the block 1 and the floor. So F1 is mu 1F and nr1 plus F2 is the frictional force acting between block 1 and 2. So this is mu 12 nr2 minus P cos 45 degree. Cos 45 degree is 0.7071. So this will be 0.7071 P is equal to 0. Okay. The coefficient of friction value between block 1 and the floor mu 1F is given in the problem as 1 by 3 into nr1 plus Coefficient of friction value between blocks 1 and 2 is given as 1 by 4. The value of NR2 has been calculated in the previous step of the problem as 88.29 minus 0.7071p is equal to 0. Okay. We can simplify this expression as 0.7071p minus 0.3333 into NR1 is equal to 22.0725. We can keep this as equation 2. Now we can apply the second equilibrium condition for the forces acting on block 1, that is summation V is equal to 0. Okay. Here the normal reaction force NR1 and this vertical force component of the subjected force P, that is P sin 45 degree, are acting along the positive y-axis direction. So NR1 plus P sin 45 degree. Next, the weight components of blocks 1 and 2, that is W1 and W2 are acting along the negative y-axis direction. So minus W1 minus W2 is equal to 0. Okay. This becomes NR1 plus sin 45 degree is 0.7071p minus W1 as M1 into 9.81. Mass of block 1 is given as 14 kilogram. So 14 into 9.81 minus W2 is M2 into 9.81. M2 is 9 kg. So 9 into 9.81 is equal to 0. Okay. This becomes NR1 plus 0.7071p minus 225.63 is equal to 0. Okay. We can simplify this expression as 0.7071p plus NR1 is equal to 225.63. We can keep this as equation 3. We have two equations now in our hand. Equation 2 is 0.7071p minus 0.3333 NR1 is equal to 22.0725, and equation 3 as 0.7071p plus NR1 is equal to 225.63. On solving these two equations, we can get the value of P as 103.1792 Newton and NR1 as 152.6719 Newton.